So what I've done here is drive down to the edge of the field, and I wish to visit the area of interest where I'm concerned about the biomass not performing as well during this year, but also through previous seasons. So here we're looking at the PCT ag map, and I've turned on the GPS and I'm on the fence line and I'm pretty well adjacent to that area. Now what I can do is grab the latest satellite imagery from SatterMap to look at the biomass changes while I'm in the field. It's given me three choices, and I select the 25th of July, and it's going to download that image for me now. So I've got live data and I can see myself with the GPS exactly where I'm positioned. So the next process is to navigate across this imagery out into this area of poor growth, but I'm also interested in going to the edge of that to have a look whether I can see why the biomass has gone from poor to reasonably strong over a very short distance. So we'll start to migrate our way across the field now, and we'll work our way into that sort of finger of green biomass, which is indicating higher strength crop. And I'm going to go to the edge of that to see what I can see. Yep, and so here I am. I've walked across the field and I've got to the edge of that satellite imagery, which is showing me we've got a dramatic change in biomass. Just zooming in a bit, and what I'm going to do now is look at an EM38 map that we have for this field, and an EM38 is a pretty good indicator of changes of soil conditions once you're out in the paddock. So we're just working to that edge now, and I've just switched on the EM map, and we can see that where the biomass was changing quite dramatically from poor to quite good, we can also see there's a sharp edge in the EM map, and there's quite a distinct zone there that we're standing in. So now I've just downloaded the very latest soil vegetation index map, and we can see that there's good sort of correlation into the shapes of those maps and with the soil type that is indicated by the EM. So here we are, we've navigated to the edge of the biomass imagery, which we could see is very low biomass in the satellite data. So we can see the crop's quite thin there, and we can see light coloured soil showing through. And now we're looking up the rise where the satellite data indicated better crop health, but also the EM38 map was indicating a distinct soil change. So we see up here we've got greater crop cover, the crop's a healthier colour and generally better looking. Then we're looking back here at that area of low biomass and low EM, and we're looking at that light sandy soil again. So what I'm looking to do here is have a look at what these soil changes indicated by the EM map, what they might mean to crop health. And I've dug down here probably about 150 mils. We had about 8 mils of rain here just 3 days ago, and we can see that the moisture is still apparent down through the profile and coming right up to the surface. So moisture's been retained there, and it's supporting a healthier crop. So now I've moved over to the area of the field which had low biomass and also was indicated as being a different soil type according to the EM. It showed up a much lower value, and I've just dug down to about 150 mils again, and we can see after that same rainfall event that the soil has quite a different characteristic. It's quite loose and sandy and apparently quite dry. So it appears that we've got some non-wetting characteristics to this soil profile here, and likely that's accompanying that is some very low pH and some soil acidity, which is restricting the root growth as well. So those things are sort of combining to give us a lot lower crop establishment and a lot lower crop growth. So now that we've established that there's relationships between the biomass imagery and the EM map, and we've been able to accurately navigate to those in the field, we can now go back to the office and use historical yield maps to establish the financial impacts of this change in soil type, and then do a cost benefit of how we're going to correct this problem part of the field. So now we're back at the office, and we're going to look at some of the financial impacts of this apparent non-wetting soil, because we can see the biomass is a lot lower and it seems to be strongly correlated to soil type. So what we've done here is we've broken up the EM map into some 4 major soil types in the field, and then we're looking at comparing the yield in each of those zones. So we can see now that this dark red soil was where we were standing, looking at the apparent non-wetting soil, that's yielded about 1.4 tonnes a hectare in 2010. The orange soil 1.86, but the green soil, the heavier type soil types, were up to 2.3 tonnes a hectare. So we can see quite clearly that non-wetting type soil has pulled the production back quite significantly. So it becomes important then to find out exactly what it is of that chemical and physical structure of the soil which is causing the problem, and then what the remedy may be. It's likely going to involve lime, possibly some clay spreading and some delving. We don't necessarily have to treat it. We could reduce our fertiliser inputs, but the opportunity is there to correct this soil limiting factor and to unlock potential water availability and therefore production levels. So we have another view that we can look at with this field, because the assessment needs to be made that, do I just reduce my inputs because that soil has less productive capacity, or do I try and remedy that problem? What we're looking at here is the accumulative effect of this particular soil type over multiple years. So we've broken the EM map up into the same zones over 5 years of wheat yield, and we can see as we go down that those graphs have a very similar shape, where the red soil on the left is clearly the lowest producing, and the green and blue soils are the highest producing. So we can go right through to the bottom, and we can now see that over the course of that period of 5 to 6 years of wheat yield, is that dark red soil has had an average profit of a little over $60, where the better soil types have had profitability of over $300 a hectare. So sometimes the question is, do I make an investment to correct this problem? If we don't make that investment, well then virtually what we're doing is committing that part of the field to making a low profit for any year that you're going to sow it in the future.